Swimming in a pool of mercury is a thought experiment.
That opens a window into the fascinating realm of physics
Chemistry.
and human physiology.
Mercury, also known by its chemical symbol Hg,
Is a heavy, silver-dappled metal that is liquid at room temperature. This unique liquid metal has properties that are starkly different from water,
making the experience of swimming in it unlike anything else. Mercury is dense, about 13.5 times denser than water.
This high density is the first clue to what makes swimming in mercury a peculiar idea.
For comparison, humans are slightly less dense than water, which allows us to float.
In mercury, this density disparity would be amplified, making it nearly impossible to sink. Instead of the familiar sensation of buoyancy in water, you would experience an extreme form of it in mercury. You'd float on the surface much more readily, with much of your body exposed to the air above.
Moving in a pool of mercury would be an ordeal.
Due to its high density, mercury would also be significantly more viscous than water, though it's still less viscous than other liquids like honey. This means that while you could technically move through it, every movement would require more force. Your limbs would meet with considerable resistance, making swimming strokes laborious and slow. The experience would be more akin to pushing through a dense, heavy medium than the fluid glide associated with swimming in water. Beyond the physical peculiarities, swimming in mercury poses severe health risks.
Mercury vapor is toxic. Inhaling it can lead to mercury poisoning, which affects the nervous system, kidneys, and other organs. Symptoms can include muscle weakness, Poor coordination, numbness in the hands and feet, skin rashes, anxiety, memory problems,
and in severe cases, kidney malfunction and death.
Moreover, direct contact with mercury can cause it to be absorbed through the skin,
though less efficiently than inhalation. The danger is compounded by mercury's ability to amalgamate with other metals, potentially leading to allergic reactions or dermatitis. Creating a pool large enough to swim in would require a tremendous amount of mercury, posing significant environmental hazards.
Mercury is notoriously difficult to contain,
and spills can lead to long-term ecological damage, contaminating water sources, and entering the food chain. Additionally, the equipment and facilities needed to safely manage and contain such a pool would be highly specialized.
Mercury's corrosive nature to certain materials necessitates the use of specific alloys or treatment methods to prevent the pool structure from deteriorating. In this hypothetical scenario, if one were to carefully attempt to swim in mercury under controlled and safe conditions, the visual and tactile experiences would be unique.
The shiny, mirror-like surface of the mercury would reflect your image and the surroundings with a clarity unmatched by water. Droplets of mercury, unlike water, would not cling to your skin but rather form beads and roll off due to its high surface tension. An interesting physics demonstration in a mercury pool would be the buoyancy of objects that usually sink in water.
For instance, a solid iron anvil, which would rapidly sink in a water pool, would float on mercury.
This would be a vivid illustration of Archimedes' principle, which states that the upward buoyant force exerted on a body immersed in a fluid is equal to the weight of the fluid that the body displaces.
While swimming in a pool of mercury is a thought-provoking idea that captures the imagination,
it is fraught with practical, health, and environmental challenges that make it inadvisable and unrealistic. The physical properties of mercury, while fascinating from a scientific perspective, pose significant risks and obstacles.
This hypothetical scenario serves as a reminder of the unique properties of materials around us,
and the complex interplay of factors that govern our interaction with them.
It underscores the importance of respecting the properties of substances
and the environments we inhabit, reminding us of the delicate balance between curiosity and safety.